All right, today we're going to be talking section 7.2a, parallel and perpendicular slopes. So a couple of important things. If we have parallel lines, they have the same slope. Okay, the symbol for parallel is two little lines together by themselves. Often when I write it, mine tend to be a little bit slanty, but it's still the same symbol. Parallel lines never intersect, so that means they're never going to cross. If two non-vertical lines are parallel, they have the same slope. Two parallel vertical lines would both have undefined slopes. Then we have perpendicular lines. Perpendicular lines are if two lines have the same slope. They're not the same, sorry. We have m and -1 over m. Then the slopes are parallel. So in other words, if the slopes are negative reciprocals, so here's your key. They have to have an opposite sign and flipped fractions. Then the lines are perpendicular. That means they meet at a 90-degree angle, and the symbol for perpendicular is this upside down capital T. It's two little perpendicular lines next to each other. Just a special note, vertical and horizontal lines. The slope of a horizontal line, so horizontal goes this way. Its slope is 0, and the equation would be y equals just a single number. Then the slope of a vertical line is considered undefined, so our vertical lines. And if we have that in the equation, it's x equals a number. So let's look at some examples. It says determine whether the lines are parallel, perpendicular, or neither, given the graphs. Find the slope of each line to verify your answer. So looking at these, it's probably pretty easy to tell if they're parallel or perpendicular, but we actually have to verify it mathematically. So the first thing we're going to do is we're going to identify 2 points on each line so that we can find the slope. So you're looking for points where the lines intersect the grid at whole numbers. So I can use those 2 dots on line A. So then I'll draw my little slope triangle, and that's a vertical change of 2, a horizontal change of 1, and we're going down and right, which makes this a negative slope. So this is going to be -2 over 1, which will simplify to -2. Now we have to do the slope of B. And again, I said it doesn't really matter where we pick those points, so I'm going to pick 2 points on line B. Here we went down to right 1, so the slope again would be -2 over 1, which is -2. So because these are exactly the same, this makes these parallel. Now these ones, they could be perpendicular, they're pretty close to each other, so let's double check. So find a nice pretty line on G. Well, it looks like there and there would be 2 good points that I could use for G. And again, doesn't matter, as long as they're crossing a whole number so that we can count. So this vertical is 1, 2, 3. Horizontal is 1, 2. It is going down and right, so it is a negative slope. And -3/2 is simplified. So now let's look along H until we find some pretty points. Oh, there's one. There's one. So in this case, I go up 1, 2, 3, right 2. So the slope of that is 3 over 2. So those have opposite signs, but the same number. So that does not meet our criteria for perpendicular, so this one is neither. Then let's look here on number 3. It looks like C crosses over here, and then again maybe right there. So down 1 over 1, 2, 3, 4. So down 1 would make it negative, and right 4. So -1/4 is simplified. Then D looks like we cross here, maybe again right there. So we go up 1, 2, 3, 4 over 1. So rise of 4, run of 1, because we went up and right, so it is a positive slope. Whoops, let's simplify that to just 4. So that is our answer. And then these will be perpendicular because they are opposite signs, and if I flip that fraction over, we've got the right thing. All right, let's turn to the next page. So some more practice. It says determine whether the lines are parallel, perpendicular, or neither given the graphs. You have to find the slope of each line to verify the answer. So we look for some pretty points. There's one, there's one. So on A, it looks like we went down 3, right 2, so the slope is -3/2. B, let's find pretty points. Look, there's one, and there's one. So up 1, 2, 3 over 1, 2, 3, 4. So that's positive 3/4. And if I looked at that, that looked perpendicular to my eye, but it's not. That's why we need to verify mathematically. That one is neither. These ones appear to be parallel. Of course, when we have a graph like this, it is just a little snapshot of the whole thing because it extends in all directions. So we do have to double check. So that crosses, it looks like there, and maybe right there. So up to 1, 2, 3, 4, 5, 6. Oh, that was 2. And 6. So the rise was 2, the run was 6. That simplifies. Always simplify your slope, so that simplifies to 1/3. And here we have 2. Oh, here I can go closer. So up 1 over 3. So that one is also 1/3. They are identical, and that makes those lines parallel. And the slope of C. Oh, I did D. Let's do C first. Okay, so it looks like here we go down 1, right 3. So the slope is at -1/3. And the slope of D is up 3, right 1. So that's 3 over 1, which is 3. So they are flipped fractions and opposite numbers. Therefore, those are perpendicular. Okay, so what happens if we don't have the lines? Can we still determine if things are parallel or perpendicular? So now it says find the slope of a line parallel to the slope of the line that passes through each pair of points. So what we really need to do is just find the slope of those two lines because it's going to be exactly the same as the original slope. Okay, so all we're doing is finding the slope. So find slope. And the slope formula, if you'll recall, is y2 minus y1 divided by x2 minus x1. So when we do this, make sure you watch those signs and you're very careful that way. So -17 is my y value minus 0 divided by 13 minus -4. So on the top we get -17, and on the bottom we would keep change and get positive 17. And when we divide that, we get -1. And that is our answer, because if the line passes through these two pair of points and we need another line that's parallel to it, then the slope is going to be the same because parallel lines have the same slope. So again, all we're doing is finding the slope. So here we have -1 minus -11 over 5 minus 16. Again, y2 minus y1 over x2 minus x1. Keep change. That gives us 10 over -11. And technically we like that negative sign either out front or up top. So the answer to this one is -10/11. All right, number 9, we'd have -20 minus -20 divided by 4 minus -16. Keep change. That gives us 0 on top, 20 on the bottom. Doesn't really matter what we get on the bottom because we have 0 on the top, which makes this slope 0. And number 10, 9 minus 5 over 13 minus 13. 9 minus 5 is 4. 13 minus 13 is 0. Because 0 is under the line, we know the slope is undefined. If you put 4 divided by 0 in your calculator, it says divide by 0 error, so that's your clue that you have done something wrong and that it's an undefined slope. I guess you didn't do anything wrong. It means that it's an undefined slope. All right, next page. Sorry, these notes are a little bit long. Now this one says find the slope of a line perpendicular. So to perpendicular, first you're going to find the slope. Okay, so this is step 1, find the slope. Step 2, change sign and flip the fraction. And that will give you your perpendicular slope. So we're going to start by finding the slope with the points that they give us. Then we're going to flip them to get what we need. So here we would have negative 3 minus 15 over 19 minus 20. So that is negative 18 over negative 1, which is positive 18. So now to get the perpendicular slope, so the perpendicular slope, we're going to change the sign, flip the fraction. So negative 1/18 is our answer. Now you don't have to write perpendicular slope unless your teacher requires it. You just need to make sure that you are aware that it's going to be opposite or negative reciprocal from your slope that you just found. Next one, 7 minus 15 over 6 minus negative 10. So that is negative 8 over 16, which we simplify that is negative 1/2. So then to get our perpendicular slope, we are going to change the sign, which makes it positive, flip it over, it becomes 2 over 1, which is just 2. Okay, example 13, 8 minus 8 over 5 minus negative 8. So that gives us 0 over 13, which is 0. And when you have a 0 slope, that means that it's a horizontal line. So that means the line that's perpendicular to it is vertical. Or if I flip it over, I'd have 0 in the denominator. So this is undefined when we get the perpendicular slope. So that one's a little bit tricky. Next one, negative 10 minus negative 1, over negative 16 minus negative 16. So we get, negative 9 over 0, which this one's undefined. So if we flip that over, we would get 0 over negative 9, or 0 for a perpendicular slope. And our last two examples, negative 20 minus negative 18 over 4 minus negative 16. Keep change, that gives us negative 2 over 20, which is negative 1/10. So then our perpendicular slope, when we flip that over and change the sign, is positive 10. And our last example, 9 minus 5 over 13 minus 5. So that is 4 over 8, which is 1/2. So when we do our perpendicular slope, we change the sign, which makes it negative, flip it over, would be 2 over 1, which is 2. Good luck on your assignment. If you have any questions, please see your teacher.